Hello, my name is Andrew Wild, and I'm a graduate student studying science education at Stanford University.
In this video, I will explain our group's learning progression for argumentation in science. As part of the presentation, I will explain the meaning of images such as the one you see on the screen. You may be asking, what is a learning progression for argumentation in science? We define it as a research-based map of how students might improve on scientific argumentation with support over time. Our map can inform the teaching and assessment of scientific argumentation. It is the result of a 4-year research project that involved approximately 2,000 middle and high school students in the San Francisco Bay Area. This is an example of the beginning of a scientific argumentation assessment. Two students pour sugar grains into a glass of hot water. Once the sugar is poured into the water, it is stirred. After stirring, the sugar can no longer be seen. Later in the assessment, students are provided with two claims. Two students discuss what they think happened to the sugar. Laura says, "I think the sugar is gone." Mary says, "I think the sugar is still there." We issued these items to students and determined which aspects of argumentation were more and less difficult for students. By sequencing the complexity of argumentation, we created a learning progression. This is our learning progression for argumentation in science. We know you are not able to read the text, but have no fear. Soon I will zoom in and explain the components of the progression. Each row corresponds to a level of argumentation complexity. The argumentation is more complex from the top to the bottom of the table. The column on the right includes representation of the elements or fundamental building blocks of argumentation. The elements of argumentation are claim, reasoning, and evidence. A claim is an assertion about the natural world. Scientific claims include descriptions of phenomena, what caused them, and how we know what we know. Evidence is information that indicates whether or not the claim is valid. Reasoning is the explanation of how evidence supports the claim. For example, if we consider sugar being mixed into water, an argument might be, the sugar is still there. Since sugar tastes sweet and the sugar and water mixture tastes sweet, the sugar has not disappeared. The claim is the sugar is still there. The evidence is the sugar and water mixture tastes sweet, and the reasoning is the remainder of the argument. Notice that the images for the elements are shaded. This indicates that the element needs to be explicitly stated. The progression also includes elements that are not shaded. These elements might be considered implicitly in order to complete an argumentation task, but they do not have to be stated explicitly by students. In other words, the unshaded elements are quote-unquote in the head, but not written or spoken. Soon I will provide an example that will make this idea more clear. The description column includes a description of the complexity of argumentation. For example, the description student identifies another person's claim corresponds to the representation of the elements on the right. The student must explicitly state a claim, but in order to do so, the student needs to implicitly consider what the reasoning and evidence are in the argument. For example, if a student is provided with the argument about sugar and water, and then asked, what is the claim in the argument? The question would be assessing level 0B of the progression. An accurate response is, the claim is the sugar is still there. In order to be successful, the student has to explicitly state the claim. And to distinguish the claim from the reasoning and evidence, the student needs to implicitly consider these elements. The constructing and critiquing columns indicate whether the level of the progression requires students to make their own argument or find flaws in another argument. Level 0B, which requires the student to identify another person's claim, is categorized as critiquing, since in order to find flaws in an argument, it is first necessary to understand the claim the argument is making. In other words, we think of this level of the progress map as a necessary step towards critique. You may have noticed the colors in the table. These indicate 3 tiers of argumentation complexity. The number for the levels indicates the number of pieces of reasoning that the student must explicitly provide. Level 0 items do not require the student to provide explicit reasoning. Level 1 items require students to provide 1 element of reasoning, and Level 2 items require students to provide 2 elements of reasoning. The letters following each of the numbers indicate the sublevel. Level B is more complex than Level A, and so on. Our learning progression for argumentation in science has been tested with students so it can be used to inform curriculum, instruction, and assessments. Levels at the top of the map were more difficult for students than levels at the bottom. Student learning is complex, so improvement in scientific argumentation may not proceed linearly from one sublevel to the next. However, the progression is a tested map of how students' ability to engage in scientific argumentation might improve over time with appropriate support. We hope you find the materials and resources on this website useful, and we thank you for watching this video.